everyone, Sue here, welcome to my channel. While I was looking for information for my video about Leycesteria formosa, and here's a link to that one, I discovered a comment that sparked my interest. There's a reference on Wikipedia that the wood of Leycesteria formosa contains a fluorescent chemical called esqueletin. Having checked that reference, I found that the author of that 1969 paper referred to another author who in 1951 had just assumed that since other plants in the Caprifoliaceae family contained it, so should Leycesteria. I'm sure there's a phytochemist out there somewhere who will be able to confirm it, but I'm quite taken by pretty lights anyway, so I thought I'd experiment to see what happens. Now, esqueletin is supposed to fluoresce blue at 360 nanometers, which is part of the UVA range. These little 365 nanometer LED lights will emit wavelengths above and below the specified wavelength, so will produce a response as opposed to my big 395 nanometer black light bulb, which won't produce small enough wavelengths in that range. So to check my UV light's going to work in the target range, I'm testing it with some horse chestnut. I just happen to have a small chestnut sapling in the garden at the moment, and I've sacrificed a twig as I'm excited to show you this. And this has been confirmed as containing large concentrations of esquilin, which is an associated compound that fluoresces with the same UV wavelength. Esquilin is water soluble, and the release into my glass of water here is pretty spectacular, don't you think? So now I know my UV light is emitting some 360 nanometer wavelength rays, I can try some stems from my Leycesteria formosa. It's obvious the plant doesn't contain as much fluorescent material as horse chestnut. After all, esquilin was named after the horse chestnut, but there's definite evidence that the inner woody part of the stem fluoresces more than the outer part. And finally, since it's the festive season, I quickly crafted a basic star from one of the dried stems of my Leycesteria. I removed the bark as that didn't fluoresce, then I divided the stem into 6 strips and glued them into 2 equilateral triangles and finally stuck them together to make a 6-pointed star. Then I waited until it was dark, hung it up and directed UV light at it. There, that's pretty. Thank you for watching. Peace and goodwill to you all, and I hope to see you again soon.